Here, number 4, we're given some experiment with these outcomes. So here's the outcomes and the corresponding probabilities. And we want to verify that this table does not represent a valid probability distribution. So we need to show two things. So let's just talk about probability distributions for a second. If a distribution like this is going to be a valid probability distribution, we have to show two things. First of all, we have to say this. For each S, for each outcome, this has to be true. 0 less than or equal to the probability of that outcome, less than or equal to 1, which just means that for each one of these S's here, for each outcome, these probabilities, these numbers over here have to be between 0 and 1. Right? We can't have negatives, can't have numbers bigger than 1. They have to be probabilities, numbers between 0 and 1. And the second thing that has to happen is that if we add up these probabilities of those events, right, if we add these up, that has to equal 1 because the totality has to, something has to occur, so the probability has to be 1. So let's look at our particular distribution in terms of what we have here. So first of all, let's say this. For us, number 1, is this true? Let's say this. By inspection, now this is pretty loose here. By inspection, that means that we've looked at this very carefully, and we're saying that it's true, that this is true. By inspection, we're going to say for each one of these S's, right, for each one of these, that 0 less than or equal to the probability of S less than or equal to 1. So we're saying that we're carefully observing that for each one of these S's, these numbers over here, these are P of S's, probability of S's, each one of these is between 0 and 1. Okay, that's true, we can see that. Now the second thing that has to happen is that for number 2 to be true, what do we get when we add up these P of S's? Well, let's look at this. We're going to add these up. So if we add those up, we're going to get 0.3 plus 0.3 plus 0.3 plus 0.2. Well, there's 0.9 right there plus 0.2. We're getting 1.1, which is not equal to 1. So we're saying condition 2 fails. So here's what we're saying. Since condition 2 fails, right, condition 1's okay, but condition 2 fails. So we're saying since condition 2 fails, this distribution right here is not a valid probability distribution.